Good morning. So we're going to get started. My name is Amitai Rotem. I'm from the Windows Defender ATP product team, and we're going to talk about ransomware, or more specifically, how to prevent ransomware in your organization. So when I say Windows Defender ATP, I mean broadly the suite of products are advanced threat protection, and there's a lot of different components, as you might have heard throughout the week. Today, specifically, what I'm going to talk about is the attack surface reduction parts and the next-gen protection. And I advise that you go online or look at the other theater sections to learn about the other parts. So when we want to prevent ransomware, we can kind of look at this as an onion strategy, right? Protection in layers. The first one we want to protect is detecting via antivirus. But if that's not enough, we want to reduce the attack surface so that the harm that the ransomware can do is dramatically reduced. If that's not enough, right, and we weren't able to protect it at that point, we want to basically limit the capability to cause the harm. In our case, in ransomware, that's to encrypt. And then finally, if that's not enough, we want to prevent the execution of the malicious content. So really, when you look at protection, and when we look at it from a Windows Defender ATP perspective, we look at it that you've got all these layers. Preferably, you should use all of them, but you can pick and choose as well. And sometimes some will work better, some less, depending on your organization. So let's start with that first layer, the antivirus. When you think of antivirus, you think of the traditional signature-based antivirus. You know, there's some researcher sitting somewhere in corporate headquarters writing, if this hash, then that. And what Microsoft has done is said, we have huge intelligence. And if you listen to the previous session, the intelligence security graph, you learn about our billions of signals. We see over 1 billion endpoints month over month. We see 400 billion emails through Office 365. But we also have a search engine that goes and traverses billions of URLs, as well as user logins through Azure Active Directory. All of those together give us this big data trove that we can then apply machine learning on. Now, when we think of machine learning, it's not just this one thing, right? Every booth probably here is going to talk about machine learning, right? They're going to say, hey, we have this one model. So we look at it as another piece in the puzzle that's going to protect you. The first is the supervised machine learning. So our researchers sitting back in corporate headquarters building these machine learning models. And actually what we found, that for every malware sample that our researchers analyze, we are able to block 4,500 other samples. 4,500 other samples that were unknown are blocked because of that one researcher rule. The other part is the unsupervised learning. That's just as important. We want to remove the human biases when we are doing malware investigation. So we're looking for those unknown, and for those anomaly detection, or running anomaly detection, to find those things, right? Because a human is going to think, well, we probably shouldn't look at these files, or we don't need to look at this content. Even when they're building ML models and they're choosing features, they might think, maybe that feature isn't that important. That's where we have those unknown unknowns, and we just let it loose on our whole big data trove. Now, as I mentioned, there's no one ML model. Actually, we have many dozens of concurrent ML models that run, because we don't believe that there's one that will solve everything, right? And we look at it as this pyramid. First and foremost, instead of delivering signatures to the client computer, right, to your user's computer, we're going to deliver local ML models. These models come and get updated multiple times a day. And what they do is they deliver protection in an offline mode and within milliseconds, all locally. But if that is not enough, and that computer is cloud connected, we deliver our protection through the cloud by uploading the metadata of the threat, whether it's file-based or fileless-based, to our detection engine. There, we can run more ML models. Now, you may ask then, why don't we deliver those same exact ML models back to the client? One is performance, right? We have the compute power. We don't want the end computer's CPU to be bogged down. The other is reverse engineering. The first thing that a malicious actor is going to do, right, if we deliver all our smarts down, is just run their payload until we don't detect it, and then they're going to ship it. By putting it behind the cloud, we have that extra layer of protection. Now, in almost all cases, this is enough. This is where our story ends. But what we introduced in Windows 10 is the ability to hold the file and actually upload that sample to the Microsoft Protection Service. So the file cannot run. A traditional antivirus, what it does says, if I can't deterministically say that this file is bad, I'm going to let it run. So if it's an unknown file, it's going to run. What we have done in Windows 10 is said, let's hold the sample, let's go through these layers, and at this point, let's wait. And that's going to take seconds. For consumers, we limit that to 10 seconds, and that's usually enough. But actually for enterprises, one of our enterprise features is saying you can actually hold this file for up to a minute, and your end user in your corporation is going to get a notification saying IT is scanning that file. And we actually let you at this level in an enterprise say, I would like you to be more aggressive. This is the CEO's computer. They shouldn't be running anything unknown. Or this is a frontline employee. Why are they trying to run unknowns? So you can actually tailor that protection here. If that's not enough, unfortunately, maybe that 1 minute time passes, and in the order of minutes, what we'll do is spin up a VM in our cloud and do what we call detonation, right? We'll run the actual file and look at what it's actually doing in runtime. What registry keys is it touching? What files is it touching? And again, run ML on that. So what I'd like to do with our time here is actually talk about a little real-world cases, right? Not just the theory. So the first case that we're going to talk about is the sample analysis-based one. So as I mentioned, unfortunately, some other layers weren't enough. And this is a real user about 2 months ago out of Wyoming, Windows Server 2016 at around 3:30 a.m. So the first suspicious thing here is, why is anyone manually running something on a server computer at 3:30 a.m.? That should probably, light some alerts. But in this case, what we did is we held the file. Now, if it actually had run, this is what it would have looked like, and encrypted the files. So this was a zero-day ransomware that had never, ever been seen before. This was the first infection, or potential infection, that we saw in the world. What we did is we held that file, we uploaded the sample, and statically looked at it. So we weren't actually executing in our cloud, but we were looking at features, right? So we were looking at, if we were to run this through emulation, what was it going to do? The other thing we did is we looked at our low-fidelity detections. What are low-fidelity detections? Those are many, many detections that we have on files that we don't really trust, right? They're extremely noisy. We're never, ever going to block on them. But feed that into the ML model as signals together with the emulation and the static file attributes, right? Where did the file come from? Was it downloaded? What IPs did it come from? We actually had a multi-class DNN model, right? A neural network model that could say a little over 90% probability this is malware, and it gave it kind of a generic name, in this case, Asden. Why is it a generic name? Because no human researcher was ever involved in this, right? This all happened automatically, and actually all this happened within 8 seconds. So the end user, sure, they got a pop-up saying, you can't run this file yet, but they didn't need to do anything, and the virus was stopped. And like I mentioned, what's cool about this is this is a zero-day ransomware, never seen before. So, I wouldn't be as excited had this been a malware that's been out there for a few hours and researchers were looking at it. This was the first infection. And this is a little bit of a graphical representation, right? We're holding the file, we're uploading the metadata about it. Our service is saying, nope, metadata is not enough. This is a first seen malware or potential malware. Give me the file itself. The file is uploaded. Now, we take privacy very seriously at Microsoft. So a few things when we upload the files. First of all, these are files we deem safe. What are safe files? Files that have a low chance of having any PII in them. They are usually executables, DLLs, or maybe the macro portion of Office files, right? We're not going to upload the PDF. We're not going to upload an Excel sheet. And so we don't see a lot of value in that in protection. On the other hand, we don't want to get your sensitive information. As an enterprise, as a commercial customer, you're able to limit these. And actually, if you use the full suite of Windows Defender ATP, you can actually even limit where we store those samples. So if you want to keep them in the EU, you can keep them in the EU. You want to keep them in the United Kingdom, you can do that as well. Now, after a few hours, obviously, that's where our kind of automation kicked in and said, oh, now we're seeing this dozens and dozens of times. Let's actually attach a family name to it so that if you're ever in your security operations center and you want to do kind of look in hindsight what was happening, there's some encyclopedia that you can look up and see what happened, right? Because that generic name ASDEN is not going to tell you too much. So, antivirus, that's great. I'm going to be the first to tell you it's amazing, it's awesome, but it's not the only layer of protection. Unfortunately, sometimes something is going to slip through. Maybe you didn't enable the sample collection policy. You're not allowing us to collect that file, or for whatever reason, we weren't able to collect it. So now let's try to reduce the attack surface. This is something new that we added in Windows 10 version 1709 that came out last October, and we've been consistently improving. We've layered these attack surface reduction rules into several categories: Office, script rules, and email rules. And the point of attack surface reduction rules is saying, whether it's antivirus or by corporate policy, we weren't able to stop something, can we limit what it can do? So for example, if I were ever to come to a commercial customer and say, you should disable macros. Macros are bad. They are a huge infection vector. They'll laugh, right? They'll say, I can't do that. None of my employees are ever going to be productive. So what we did is we built these kind of HIPS rules, right, to say, well, should your Office macro really be able to run other executables? Not really, right? But actually, maybe it should for some employees, right? So you can granularly configure and say, maybe for finance employees that have very complex Excel sheets that might need to run other executables, that's fine, or trusted PowerPoint plugins. But for your general population, your employees, we don't want that to happen. Same thing about obfuscated macros. We see a lot of attacks coming in, and I think we're going to see a lot more in 2018 around coin miners that use these obfuscated macros, whether they're PowerShell or JavaScript or VB script rules that say obfuscated macros shouldn't run in my organization. Now, this is very specific to your organization. The reason we're not putting this into the operating system is because you might be running obfuscated PowerShell. Maybe your IT department decides that that's the way they want to deliver your custom scripts to employees. So these are different rules that you can kind of run. And actually now in 1803, the version that's just about to be released in a few weeks, we've added a couple more layers. Lateral movement, because that's the first thing that a sophisticated attacker is going to try to do in your organization. So flagging and blocking potential credential stealing, as well as running processes through WMI and PS exec, right? Because these are very sensitive things. The other is polymorphic payloads. We have seen that 99% of suspicious files, of malicious files, are only ever seen 10 times or less in the wild. 99% of malware is seen 10 times or less. Now, with our data trove, that means that if we ever see a file that's unknown, right, we haven't seen before, there's a high probability that it's malicious. Whether that's through Windows Defender Smart Screen or through our other telemetry channels, we're able to say, you probably shouldn't run it. So we're introducing a new ASR rule, a new attack surface reduction rule that says, if this executable is going to run for the first time on this computer, let's see what the Microsoft intelligence is saying. Oh, its age is very new, and it hasn't been seen a lot in the wild. There's a good chance it's malware. Therefore, let's block it at this point. And that's exactly what new, zero-day ransomware is afraid of. So let's go over to a demo, because I want this to be a little more realistic. And by the way, we have limited swag that we can give out. So if you tweet out something about this, we will give you some swag. So let's look at this potential malicious VB script. So basically what it was going to do is create a process and run Notepad. I'm going to go to our demo site, which is open to you as well, demo.wd.microsoft.com. And I'm going to run the attack surface reduction demo. In this case, it's as simple as basically adding this or running this PowerShell script. There we go. Let me actually run it first. So, do this. So this is when my protection is not on. There's a VBS. It's going to execute. I'm going to do what every user in the enterprise is going to do, which is actually let it run. It's running a security scan. It's letting me run. Yeah, sure, let's run this. And unfortunately, it was able to run Notepad. So Notepad open. Now, all I have to do through System Center, Intune, or here through the command line is actually run that PowerShell script. And now, if I run that exact same VB script, basically, it was blocked from running. We'll notice returned result 2, error, and PowerShell Notepad never ran. The other part is controlled folder access. So controlled folder access is that next level of saying, well, if we do let that application run, at this point, we don't want it to write to sensitive directories. And that's, again, something we introduced in 1709. So in this case, I got this super calculator from who I thought was a friend, but probably not. And I've got my picture here in this directory. We're going to run super calculator. And now antivirus is going through this. Attack surface reduction is going through this. Maybe I didn't enable the right rule. And it's going to run. And unfortunately, it encrypted my files. Now let's go back to my picture directory. And it's encrypted. I've got to pay the ransom. And it's very unfortunate for me if I'm in an organization. That means downtime and loss of productivity. Now, all I need to do as an organization, whether through System Center, Intune, or through the UI, is go into virus and threat protection, ransomware protection, turn on controlled folder access. At this point, before this executable is actually going to run, it's going to call into the intelligent security graph, find that this file does not have good reputation. Now, it doesn't need to know that it has bad reputation. It just needs to know this is not a prevalent good file that Microsoft knows about. And look at that. It tried to encrypt my files, and it failed. Now, you can run these demos through our site, obviously, but you can also try and run your own scenarios. So far, exciting? Exciting? Ransomware protection? So that was controlled folder access. Now, finally, is prevent any execution. This is really the hammer. We announced Windows Defender Application Control in 1709. And the point of application control was to say there's a lot of other kind of whitelisting, blacklisting technologies out there, including Microsoft's own App Locker. And they're wonderful. They're great. No one implements them. It is extremely hard to implement a whitelisting, blacklisting. Because if you blacklist everything and then just whitelist the allowed apps in your organization, your IT department has to run around every day and update that list. Oh, there's a new Google Chrome out there. There's a new plugin out there. I got a help desk call from someone, right? So what we wanted to do is let's take that intelligent security graph one layer further and allow you to actually say, I will not let anything run unless I've deployed it through System Center or through Intune, or potentially Microsoft says, we trust it. And this is how simple it looks. Literally in Intune, you've got two dropdowns that you can do to enable, or just audit. So if you're not still convinced that you want to run this, or you're worried about the false positives, run it in audit mode. If you use the Windows Defender Security Center for your monitoring, you will get those signals and be able to look and see what's happening in your organization and then tailor your policy. So those are kind of the 4 layers of protection, right? We start with Windows Defender Antivirus to Windows Defender Exploit Guard attack surface reduction rules, ransomware protection through controlled folder access, and finally Windows Defender Application Control to make sure that you are fully protected from all directions around ransomware. Now, as I mentioned, please go later to the booth here, fill out the survey, and if you tweet something from this session and show us, we have, I think, some tote bags or something to give out. And please feel free to reach out to me here offline with any questions. Thank you.